Okay. This is test 9. Test 9, and this is question number 1. Okay. And they ask that when an energy source is connected to a while loop, there is a current I in the while. This current will produce a field. It means that it produces a kind of field. When we study only two kind of field. ไม่ต้องถ่ายก็ได้ครับเดี๋ยวก็มีเดี๋ยวผมอัพโหลดให้อันนี้ดูอันนี้ดูก่อนว่าเราตอบอะไรนะครับ This current will produce a field pass through the loop. If you guess, it should be magnetic field pass through the loop, right? It means that if we have a loop like this and we connect it with a EMF source, we have the electromotive force. This is the EMF source here, and you have the current I like this. So from the Biot-Savart law or Ampere law, we will have the magnetic field, and you can see that we have the magnetic field that point into the Y like this. So it is a magnetic field at the first place. Okay. If the potential difference from the source are increased, the potential difference are increased, the current increase, right? The current increase, and so do the magnetic field. And so do the magnetic field. Okay. Due to the law, what law here? Due to the law, some law. If you look at the next sentence, there will be an induced something force, and this EMF, you can see that we have the word EMF here. So it means that this is the same as the force here. So it should be the electromotive force. Electromotive force, and the law that relate to the induction of the electromotive force is a Faraday's law. Okay. This EMF will try to This EMF will try to, okay, so if we follow the Faraday's law, it means that the induced EMF will try to make the induced field that will against the change of the original field, right? Here, you can see that if we look at this circuit, okay, if this EMF is increasing, it means that the magnetic field here is increasing. So it means that the induced EMF should produce the current in this direction. Okay. To create, you can see that if I say that this is I induced, the induced current will create the magnetic field. Will create the magnetic field in the opposite direction of the original field. So it means that the induced current will try to the induced EMF will try to decrease the net current, right? Will try to decrease the current or the net current to, when the net current decrease, it means that to decrease the magnetic field too. The self-inductance L of the loop is defined in the term of induced EMF and the current I as the EMF is equal to the L di by dt. This is the definition of the self-inductance. Okay. And from the induced EMF, the energy source needs to supply additional energy to the loop to overcome the induced EMF. It means that if you want to maintain the current here, the energy source, this EMF source, the original EMF source, need to supply some energy to overcome this induced EMF. And this energy will store in the, again, magnetic field, will store in the magnetic field. When the current is increased from 0 to 1, the total energy stored is equal to the 1/2 1/2 of L I square. Okay, 1/2 of L I square. So this is the formula for the potential energy. Okay, so that is for the test 9-1. Next, we will look at the test 2. Okay. Consider the voltage phasor in the figure. Choose the figure that shows the instantaneous, the instant of time that at which the instantaneous voltage is maximum. Okay. And the figure is like this. A is